Good day everyone. This is the lecture for week number 5 of IE 206 Industrial Materials and Processes. So last time we have discussed about the two industrial processes, which are the first the casting and forming processes. So now we will be discussing the part 1 of the machining processes, which is the conventional machining. So there will be part 2 of machining processes. So for this lecture, after we finish this, you should first discuss what machining process is all about. Second, know the different machines and type of machining operations. Then third, describe the tooling used in each machining process. Fourth, you should evaluate and analyze the different types of machining process. And fifth, describe and classify the different chips produced in each cutting tool. Alright, so let's go to the introduction. The introduction to machining process. So when we say machining, it is the most commonly used process to manufacture metal objects, okay, parts or tools, because in a manufacturing process, removing materials is very common. So removing materials, such as in the manufacture of a metal product, is called machining process. So how do we remove metal materials from a metal workpiece? So we use cutting tools, okay, to get rid of those unwanted materials, for us to convert it into our desired shape. Okay, so this process is also called as subtractive manufacturing. So from that word, it is a material subtracting process. Okay, so we utilize machine tools, okay, such as the machines used in 3D printing, which uses controlled addition of material. So another meaning of machining is that it is a part of manufacture of many metal products, but it can also be used on other materials such as wood, plastic, ceramic, and composite materials. But here in our discussion, we will focus on metal products. Okay, next. So here are the metals that can be machined. First is the stainless steel. So you notice that stainless steel is the number one material also in the forming process. So it is also the number one material here in the machining process. So it is used for precision machining, offering the advantage of strength and resistance to corrosion. We all know that stainless steel is a very popular material used for products that are used with the presence of moisture, okay, so that it can resist the effect of those moisture, which is the corrosion. So example of those products are automobile parts. Okay, then next is aluminum. So it is lightweight, easy to work with, and inexpensive. So this is the number 2 material again, just like in our last lesson, the forming process. Aluminum is very useful in every industrial process because of its lightweight property, and it is inexpensive. The next is brass. So it is another economical material used for machining, but should not be used in semiconductor products. Why? Because brass has zinc and tin in the material. So zinc and tin will hinder the function of semiconductor products. The next is titanium. Titanium is strong, lightweight, and corrosion resistant, but more expensive, of course, and difficult to work with. Okay, so titanium material is very useful for products with expensive prices, such as the body of expensive automobiles. The next is copper. Copper is a versatile and strong metal and works well as an electrical conductor. It is also used in machining process. So I know that you are familiar with our wirings, electrical wirings in our house, in your houses. So they are made of copper. Okay, and the next, here are some of the terms that we should be defining under the machining process. First is the machinist. So he or she is the person who specializes in machining. Then fourth, computer numerical controls, or CNC. This term is the term that I always mention to you when I'm discussing about automated process, industrial process. Okay, because this machine utilizes computerized process. Okay, so it is a computerized material removal machines that are used to control the movement and operation of the cutting machines. So you need only to program it for it to work by itself. Then next is workpiece. Workpiece is the work or material being processed. So usually it is the industrial material, the workpiece. Next is the machine tools. So the tooling used in material removal process. Machine tools are usually harder than the workpiece, in order for it to cut the workpiece and for it to be not damaged by the workpiece. Okay. The next is mild steel. It is a ferrous metal suitable for most general engineering applications. Okay, so usually mild steels are used as workpieces. And the tool steel, a carbon steel suited for tooling materials. So this is a very hard metal. So it's very hard for the purpose of cutting workpieces such as the mild steel. Then next is the carbon steel, still having a higher percent of carbon content, from 0.5 to 2.1% by weight. So it is much harder than the tool steel. Okay. So this is the most common used tool, okay, in machining. Then next is here are the machines used in machining operations. First is the most common one, which is the lathe machine. So it it involves workpiece which is clamped to the chuck of the lathe machine, as well as its spins. So later on, your activity will be watching the video of lathe machining process, and you will be documenting it. Okay, so for the definition, let's just define it. Okay, so it is a rotating machine. The part that rotates to it is the one that holds it. It's a cutting tool. Okay, so the cutting tool moves either in a perpendicular or parallel direction. Okay, that is parallel to what? To the workpiece, to remove unwanted material. Okay, so the lathe machine is classified into two. First, the traditional or the manual type. Okay, so this the process that you will be watching is the traditional or the manual type, because it is the most common used machine in every machine shops, okay, or fabrication area. Okay, then second one is automated or CNC type. So this is not commonly used in fabrication or manufacturing area, because it is more expensive, okay, than the traditional one. The next is the turret lathe or the turret lathe machine. So it is a special purpose lathe commonly used for repeated manufacturing of parts, okay, with a tool holder that enables the machine to perform a number of cutting operations. That is why it is called as turret. It involves repetitive movement, okay, for it to process many workpieces at a time. Okay, so you will be watching it, or you will be seeing it in the next slide. The lathe machine, lathe machine. Okay, then next is the drilling machine. So another machine used in the machining operations. So it produces cylindrical holes in solid materials. That's why if you are familiar with the drilling process, you know already that the finished product must have holes in them. Okay, So it is one of the most important machining process and preliminary steps in producing finishing holes. So it is used for products with features of holes. Then third is the boring machine. So boring machine is used to refine the dimension and accuracy of a drilled hole and is divided into two types, meaning the boring machine is used after you use the drilling machine. So boring machine is for more precise holes. So it comes with two types. First is the vertical boring machine. So used to machine very large heavy casting. That's why it is called vertical boring machine. So that's for it to hold large heavy casting. Okay. While the boring bar is held stationary. The next is the horizontal. So it holds the workpiece stationary while the cutting tool or boring bar is rotating. So you should know the distinct difference between the two. Okay. Next is number 4, machines, which is the milling machine. So milling machines uses rotating cutters to remove material, while the table on which the workpiece is mounted, the table itself moves. Okay, and the cutting tool is stationary. So here in milling machine, you should remember that the cutting tool is stationary while the table is moving. So it has types. So the first type of milling machine is what we call as slab milling. So it is also called peripheral milling, where the axis of cutter rotation is parallel to the workpiece. Okay, so the keyword here is parallel to the workpiece. Okay, so the rotation of the cutter. So it is a slab milling. Then face milling is uses a cutter that is mounted on a spindle having an axis of rotation perpendicular to the workpiece surface. So that's the difference of face milling to slab milling. Although you will be watching the video later on, so that you can see it by yourself. But in the definition, the difference between slab and face milling is the direction of the rotation of the cutter. Okay, with reference, of course, to the workpiece. Then third is the end milling machine. So the cutter usually rotates on an axis perpendicular. So that meanings end milling is same with face milling to the axis, although it can also be tilted to machine tapered surfaces. So there is just an additional feature of end milling, but it is similar to face milling. So generally there are two types of milling machine: the vertical and the universal milling machine. Okay, when you say universal milling machine, it is a combination of different types of milling operation. This machine can perform all this type of milling operation. The next is the planing machine. Is used primarily for machining large flat surfaces and also those with various cross sections with grooves and notches. So that's why it is called planing machine. It smoothen the surface of the workpiece, okay, in a planing motion. So cutting tool is fixed on the workpiece, or rather the cutting tool is fixed on the planing machine while the workpiece moves back and forth. Then sixth is the shaping machine. It is similar to planing machine, only it is suitable for smaller workpieces. Okay, so you should remember that cutting is moving and the workpiece is stationary. Okay, so that is also the difference. In the planing machine, the workpiece is not stationary, it moves back and forth, while in a shaping machine, the workpiece is stationary. You should remember those differences. The next is sewing or cutting machine, used for cutting shorter lengths of metal. So this is the most commonly machining operation that we can see. Okay, the common cutting of materials using a saw, okay, or a hacksaw is a milling operation, or rather a machining operation. Okay. Then next, the broaching machine is used to produce square holes, keyways, spline holes, etc. So when you use broaching machine, you can produce many different shapes of a hole. So it consists of many teeth. That's So it is for making many shapes of a hole. Looks like a file arranged sequentially. So it is push or pull and takes a series of progressively deeper cut. Okay. Then grinding machine used for sharpening of machine tools and the aid of an abrasive wheel. Okay, so grinding machine. This is also very common. Have you ever seen a market vendor who is sharpening his or her knife? So it is in the form of grinding. Okay, grinding process. Okay, so a grinding machine is commonly used under the machining operation to sharpen those tools. Then 10 is the ECM or EDM, or the electrochemical machining, or ECM, a non-traditional machining that uses corrosive sparks or chemicals. That's why it is called electrochemical. The combination of electric charge and chemical components. While electric discharge machining, or EDM, uses a spark transmitted through a dielectric fluid from an electrode to the surface of a conductive surface. Okay, so when you say dielectric fluid, it is a kind of solution, okay, a solution that has the ability to maintain an electric field. Okay, so that electric field mobilizes the electrodes, okay, in that solution, so that those mobilization makes the material removal on a workpiece. Okay, so that's the electric discharge machining. Alright, so let's go to the machineries. So this is the pictures or illustrations for the machines that we have defined a while ago. So this is the lathe machine. It has many different parts. Okay, so the first part here in the left side are the headstock assembly, or the adjustment, okay, for the headstock. Okay, so usually the headstock is the one that holds, okay, the workpiece. Okay, then this is the feed selector. So it's another part of the lathe machine that is used in selecting different options for holding the tools. Okay, so this is the carriage where in the workpiece will be laid on. The apron. Okay, so the apron contains the adjustment tool. Okay, that adjusts the distance of the workpiece to the tool. Okay, next is the cross feed hand wheel. So that is the wheel that is used by the machinist to move the tool. Then you have here the saddle. Okay, the saddle holds the control control parts that is used by the machinist. Then you have the clutch, so another control part of the saddle. Okay, so the next is the hand wheel. So hand wheel is used for adjusting the tool. Then the tailstock, the one that holds the tool. Okay, and what is this? The cross slide. Okay, so another part of this controller, the cross feed hand wheel. Okay, the waist, so it is part of the carriage, the compound rest, wherein you can select the different grip for the workpiece. The tool post. So here you can put or lay different tools. Spindle with chuck. So here you can put the workpiece that it can be rotated in this part. Okay, so next is the drilling machine. So the drilling machine has also many parts. Okay, so this is the column support. Okay, so it makes the machine stable. So the table wherein you will be putting the workpiece. Okay, the table support, of course, so that it is stable, and the column that holds the upper head, or the upper upper tools. So here is the head lock screw, okay, so that you can lock the distance that you have choice, or you have chosen, okay, in the process. And the belt tension knob, so an adjusting a control for adjusting the tension, okay, of the tool with the grip. Then the motor, the one that enables the rotation of the tool. The cover, of course, cover for the electric components or electronics components. Then on or off switch key. So feed handle, okay, so that is used for adjusting the distance of the tool. And of course the chuck, the one that is holding the tool, okay. So next, we have here the boring machine. So we have here the boring machine is very much similar to lathe machine, but as you notice that it has simpler number of, or smaller number of parts, okay. So we have here the headstock, okay, so this is the one, just like the lathe machine, it holds the workpiece. So we have the cross slide, okay, so that holds the tool, okay. Then a table saddle, then a boring head, okay, so that it is the one that rotates, okay. Then this is the workpiece that you have mounted on top, and here is the cutter on the center. Then we have the milling machine. It has many different parts. So what kind of milling machine we have here, okay, in the picture, okay. So we have a milling machine that is, okay, we have here a face milling or end milling machine, because if you put the workpiece here in the table, it is perpendicular, okay. It is the tool or the cutting tool is perpendicular to the workpiece, okay. The next is we have the planer machine. It is very large machine to accommodate very large workpieces, such as those large sheets of metals, okay. The next we have the shaper machine. It is more or it is smaller than other machines, because we can only shape limited size workpiece here, okay. Then we have a cutting machine, or the bandsaw, okay. So here we have the motor drive, okay. Then we have the hydraulic cylinder that pushes the tool. Then hydraulic pump and reservoir. The saw head, so the saw head is the one who holds the cutter or the saw, okay. The electrical panel, the work table, so working table, the workpiece will be laid here, okay. The coolant pump, so that's a part of the machine. Vice handle, so this will be the adjusting handle, okay. The next is the broaching machine. So the broaching machine, we have here the broach, or the tool, okay, the tool to make the broaching process. So this is the workpiece, the block of workpiece, okay. Then we have the fixture for the workpiece to be stable, and of course we have the machine, okay, the hydraulic cylinder that makes the process to have a rotating motion, okay. The next is we have here the grinding machine. So it is very simple grinding machine. So we have on the each side we have here on the each side the two wheels, okay. So we have here the coarse wheel. It is where we can grind workpieces, okay, using a coarse texture of the wheel. Then we have a fine wheel. Here we can use it to smoothen the surface of the workpiece. The next is the ECM machine, okay. When we see ECM, that is the electrochemical machining, okay. So as we have defined it, it uses a chemical solution, okay. So you'll be we will understand this better as we watch the given video, okay. So I will be letting you watch a given video for this process. So it is very complex process. Okay, so we'll be watching it using a sample video. Alright, so for us to better understand the electrochemical machine or ECM process, let's watch this video.
Electrochemical machining process. Electrochemical machining, or ECM, is a method of removing metal by an electrochemical process. It is normally used for mass production, and is used for machining extremely hard materials, or materials that are difficult to machine using conventional methods. Its use is limited to electrically conductive materials. This video will cover the following about electrochemical machining process. 1. Working principle. 2. Construction. 3. Working. 4. Applications. 5. Advantages and disadvantages. Working principle. Whenever the two electrodes, anode which is connected to positive terminal, and cathode which is connected to negative terminal, is immersed in an electrolyte, such as NaCl. When the voltage is applied across the two electrodes, the material removal from the anode starts. The anode and cathode is placed very close to each other without touching. In ECM, the material removal takes place at atomic level, so it produces a mirror finished surface. ECM working is opposite to the electrochemical, or galvanic coating, or deposition process. Let us understand the chemical reaction taking place in this process. As the potential difference is applied across the electrode, the movement of ions starts in between the tool and workpiece. The positive ions moves towards the tool, and negative ions move towards the workpiece. At cathode, the hydrogen ions takes electrons, and gets converted into hydrogen gas. In the same way the iron atoms comes out from the anode which is workpiece, as Fe++ ions. Within the electrolyte, the sodium ions combines with hydroxyl ions and form sodium hydroxide, and ferrous ion combine with chloride ions and forms ferrous chloride. Also iron ions combine with hydroxyl ions and form iron hydroxide. In the electrolyte, the FeCl2 and FeO2 produced, and gets precipitated in the form of sludge, and settle down. In this way, the material is removed from the workpiece as sludge. The various reactions taking place in the electrochemical machining process are as follows. Construction. Electrochemical machining setup consists of following parts. Power supply. It requires a DC power supply for machining purpose. Electrolyte. The electrolyte has three main roles in the ECM process. It carries the current between the tool and the workpiece. It removes the products of the reaction from the internal electrode gap, and it removes the heat produced from the passage of the current. Tool. Tool is a replica of the shape required on the workpiece. Tank. This holds the electrolyte in which the tool and workpiece are immersed. Workpiece. Workpiece holding table. Pressure gauge. It shows the pressure at which the electrolyte is supplied to the tool. Flow meter. It shows the rate of flow of electrolyte to the machining area. Flow control valve.
Okay, so you don't need to know all of those specific details. Okay, so you have just to know why it is called as electrochemical machine. It uses or machining. It uses the combination of the chemical, which is electrolyte, and the flow of of electricity on the tool. Okay, to remove the materials from a workpiece. Okay, so that's what you have to know about it. Okay, so let's move to the second one, the electric discharge machining.
Electrical discharge machining. EDM, or electrical discharge machining, is a non-conventional machining process. Used for machining very hard materials which otherwise cannot be machined using conventional machining processes. This process is also called as spark eroding, spark machining, wire erosion, wire burning, etc. In this process, the metal from the workpiece is removed using high-frequency electrical spark discharge from graphite, or soft metal tools, which serve as electrode. Note, this process is only suitable for metallic or conductive workpiece. This process is very similar to how a spark plug works in the petrol engine. It creates an artificial bolt of lighting in the combustion chamber. The electrical energy that it creates is extremely high. In order to create a spark, The voltage of the spark plug is nearly between 20,000 to 100,000 volts. If you are interested in the working of the engines, I have provided a link in the description below. This video will cover the following about the EDM process. 1. Working principle. 2. Construction. 3. Working. 4. Application. 5. Advantages and disadvantages. Working principle. The working principle of the EDM process is based on workpiece metal erosion, with the application, or spark discharge between the tool and the workpiece. When two current-carrying conductors, that is, anode and cathode, are brought in close proximity, an electric arc is formed between the two conductors, due to which, at the point of contact, a small amount of metal is eroded, leaving small cracks. This spark generates intense heat, causing the metal in this zone of spark to melt and evaporate. When both the electrode, that is, anode and cathode, is made of the same material, the electrode connected to the positive terminal erodes faster. Therefore, the workpiece is generally connected to the positive terminal, that is, it is made anode. Generally, a small gap of 0.005 millimeters or 0.05 millimeters is maintained between the tool and the workpiece. The spark occurs where the tool and the workpiece are the closest. Here the shape of the tool is the same as the impression to be generated on the workpiece. To increase the effectiveness of the process, the tool and workpiece are immersed in the dielectric fluids, such as hydrocarbon and mineral oils. Construction. DC pulse generator. This converts the AC pulse DC supply, responsible for
Okay, so that's all that you should know about the electric discharge machining. It is very similar to the one that we have watched, which is the electrochemical machining. So the only difference is the application of anode and cathode. Okay, so here in electric discharge machining, or EDM, the workpiece is the anode, or in the positive charge, while the tool is in the cathode. Okay, so it also uses a chemical solution here, just like in the electrochemical machine. Okay, so let's move on to another process. Okay, so here are the machining operations and tooling. First is drilling. So it is a process of making holes that are created in the metal through the use of a drill bit of different diameter according to size of hole to be drilled. Okay, so let's watch an example of drilling operation. Alright, so first is the drilling. Okay, drilling process. Let's watch it, how it is being processed.
The drilling process typically starts with a spot or starter hole. Then, the engineering drawing is consulted to identify the size of the hole to be drilled. In this example, the hole is specified as a through hole that is 7 millimeters in diameter. The tool used to drill this through hole is a twist drill of the required diameter. In this next example, a blind hole is required, which also follows a starter hole. The engineering drawing requirement shows a 1.25-inch blind hole that is 750 thousandths of an inch deep. The tool used to drill this blind hole is a twist drill of the required diameter, which is programmed to drill to the specified depth.
Okay, so that is the basic of drilling process. So we use a tool that is capable of achieving the specifications made in the engineering drawing. Okay, so next we have the turning process. Basically, lathe operation where metal is removed from the workpiece. So let's watch it, the turning operation.
Turning can be accomplished on a variety of CNC machines or on a conventional lathe. As the workpiece rotates, the cutting tool moves in a linear direction, either parallel to or perpendicular to the axis of rotation of the workpiece. The cutting tool movement is determined by the specification of the feature to be generated and by the position of the workpiece. One example of a turning process is facing. During the facing process, the tool moves perpendicularly to the workpiece rotational axis. As in all turning processes, material removal is accomplished due to the relative motion between the workpiece and the cutting tool.
Okay, so that's the term, or the tool is stationary while the workpiece rotates. Okay, so next is milling operation. One of the fundamental operation. It has different purposes such as gear cutting. Okay, so it is used in the it is a cutting tool that is called milling cutter. We have the slotting or keyways. End mill is used for cutting, cleaning flat surfaces. Uses fly cutter. So let's watch this milling operation. So first we have the face milling. So this is the tool. The tool is the one who rotates, while the workpiece is laid on the what do we call this? The chuck that holds the workpiece. So it moves back and forth. The workpiece is moving back and forth. Then we have here the end milling. Okay, again, the tool is rotating, but it is stationary, while the workpiece is moving. Okay, so that's the milling process overview. So what's the difference between face and end milling? Face milling is used for what? For making a good surface finish. Okay, so it is milling the face of the workpiece, while end milling makes deeper cut or deeper material removal. Okay, next we have the grinding process. So let's watch the grinding process. So we have a cylindrical grinding here.
Cylindrical grinding is a downstream machining operation for components that require fine surface finish in high dimensional accuracy. Grinding is preferred for machining very hard materials. Grinding has been used since ancient times. Hand-driven and foot-driven grinding wheels were used in ancient Egypt and Greece for sharpening hand tools and weapons such as swords. Grinding entails removing excess material from the surface of a workpiece using an abrasive wheel that rotates on its spindle. Cylindrical grinding is a specialized form of grinding operation that involves removing excess material from a cylindrical workpiece. Both the workpiece and the wheel rotate relative to each other.
Okay, so that's the cylindrical grinding operation. So we have the wheel here. That is the one who grinds the excess materials on the surfaces of the workpiece. Okay, so next we have the shaping. Okay, so let's watch the operation or the process of shaping. We have here the gear shaping.
Shaping is a machining process used to produce a variety of forms.
So the one that is moving here
gear and spline teeth
is the tool.
Mounted on a reciprocating rotating spindle, a special cutting tool feeds into the work, which is mounted on a rotating table. The tool cuts in one direction, then retracts slightly to avoid interference on the return stroke. As the work and cutter turn, the tooth is generated by a series of closely spaced cuts. Shaping can produce forms in bobbing, such as internal.
Okay, so that's the shaping. Okay, so it uses a tool that is moving up and down, and the workpiece is rotating slowly. And what you notice here is that it uses lubricant. Okay, to avoid making a high result, making the temperature higher, because it may affect the quality of the tool or the finished product. Okay, so that's why it is using the lubricant, oil lubricant here. So next we have the knurling process. Let's watch the knurling process. Okay, so what is a knurling process? So it is usually done in a lathe machine. So this is a lathe machine. You have the workpiece that is being rotated by the chuck. Okay, and you have here the tool, okay, that is being moved towards the workpiece. So it is being moved by the operator, and you notice that there are materials that are being removed from the surface of the workpiece because the tool is making contact with it. So let's move it forward. So you can see that the tool is now having a grip. Okay, so it has some texture, more of a rough texture. Okay, so that is knurling. Next is we have reboring. So let's watch what is reboring is. Okay, so this is reboring process. As you notice that there is already holes, okay, on the gear. So what reboring makes is that it rebores, or it makes the hole more bigger, okay, more bigger and more smoother. Okay, so that's the reboring process. So next we have the threading. Let's watch what is threading. Okay, so what you are watching here is that the tool is being adjusted to the dimension that is desired for it to impart to the workpiece. Okay, so you notice that the tool is being adjusted to the dimension that it should impart to the workpiece. Okay, so after making the tool, so it will be used here, okay, in the lathe machine. So threading is usually done in a lathe machine also. Okay, so this is the workpiece. Let's move it. Okay, this is the workpiece, and it is being lubricated, okay, to have a smoother surface. And this is the tool. You notice it removes the material, and it will be making threads. That's why it is called threading. Okay, you will notice that the workpiece will have a spiral threads. Okay, it has a pattern of a thread. Okay, that's why it is called threading. Okay, so next we have the surface grinding. Let's watch the surface grinding. Okay, so that is the workpiece. As you notice that the workpiece is very weary, or the workpiece has many has many imperfections to it. Okay, so it uses this surface grinding operation to make the surface more shiny. Okay, so let's make fast forward it. So it also uses abrasive wheel. Okay, it uses abrasive wheel to surface finish, okay, the surface of the workpiece. So let's see the finished product. So it is more shiny. The tool or the finished product is more shiny, and its surface is more fine. Next is the cutting. So cutting is the most common machining operation, right, because it uses cutting saw blades.
The Steel Demon Sermon circular saw blade from Diablo is so hot it's cool, bringing you extreme durability, longer life, and faster cuts. This first of its kind blade is revolutionizing the metal cutting industry.
Okay, as simple as it is the most common machining process. The cutting of metals or materials using saw blades. Okay, so that's the last machining operation. So we have here tools, the cutting tools in machining operations. First is the drill bit for drilling. You see this one, or you saw this one a while ago in the drilling process. We have the high-speed steel for turning. You also see this tool in the turning or milling process. You have the end mill for milling. Okay. Then you have the abrasive wheel for grinding, knurling tool for knurling, and carbide steel for shaping. Okay. And then you have the hacksaw blade for cutting. So this hacksaw is used for cutting metal workpieces. Okay, but the one that you have saw in the last video is a circular cutter. Okay, but it is they are used for both or the same function. Okay, the next is shape carbide tool for threading and gear cutter for milling. So let's go here to the advantages of the lathe machine. So it have accuracy that is very high in case if it will be used in the CNC or the computer numerical controlled lathes. Okay, because it is very a semi-automatic process. Okay, or sometimes it is a fully automatic process. It is being functioned by computer system. Okay, then another advantage is the flow of production is more because of the intervention of automatic processing. The next is it requires few operators in a manual lathe. Usually there is only one operator, okay, in a manual lathe machine. And fast machining in the lathe and the CNC lathe, because those machines are used for efficiency processing of workpieces. They are very useful when it comes to producing many materials or many finished products in a given time. The disadvantage is setting time for holding job is very high, so you need to adjust first the lathe machine before you can use it. Then next is only one tool can be used generally at a time. Okay, so you should choose the right tool, okay, for the operation of lathe machine. So one at a time. Then idle time in between the operation is high because you need a considerably amount of time when setting up the machine. Then preciseness of the job depends highly on skills of an operator. So the lathe operator should be highly skilled. Otherwise, the product that you will be making is not precise with its dimension. The next is the drilling machine. So it has accurate points, good field control, difficult to roll. Okay, retraction is not flexible, because as you can see in the video, the drilling machine is just involves push and pull, okay, motion of the tool. The next is you have the not suitable for processing deep holes and large holes. Okay, so it is only used for small holes. Then we have the boring machine. Advantage is the ability to manufacture large machine parts, okay, and fast cutting speed. So you saw in the video that boring machines are larger than drilling machines. That's why it can process more larger machine parts or workpieces. Then disadvantages, it consumes a large area for installation. So since it uses large machines, it will utilizes large areas also. Then it is expensive. Okay, the machine is expensive. and inconvenience in loading and unloading the workpiece, because the workpieces are usually in large sizes. The next is milling machine advantage. It has high production rate, reduced lead time. High accuracy of the component can be obtained. As you saw in the video, it is a process that makes finished products in a fast phase. Okay, so it can produce many products at a time. Okay, and its accuracy is very high also. The disadvantages, the machine itself, the milling machine, is high in cost. Then skilled manpower is needed also here for the accuracy of the setup of the machine. Then not suitable for cutting radial cut. Okay, so as you notice in the video, there is no radial cut. Radial cut means the cut that makes a spiral cut. Okay. The next is planing machine. So planing machine advantages: good surface finish, because you notice in the video that it finishes the surface of the metal. It makes the surface more fine and shiny. The next, it has greater accuracy, because the axis that it is functioning is only on one axis, so it is easy to be accurate. Then more than one tool can perform at a time on the workpiece. Okay, low maintenance required also. Disadvantages is it is not suitable for small parts production. So you will use planing machine if you will be making a large amount or a large volume of workpieces. Then it has the high investment costs. So this is common because you will buy those machines such as the planing machine. So a skilled worker also is required here. The next is the shaper machine. So low tooling cost. Okay, so those tools are readily available with the machine. Then workpiece setup is easy, good for small production parts, can be readily changed from one job to another. Okay, so the setup is very fast here in the shaper machine. Disadvantage is low cutting speed. Okay, then only one cutting tool is used, limited capacity when it comes to length of the workpiece, so you can only make smaller workpieces here. Okay, then for the activity, as I said a while ago, you should watch a video of a lathe machine operation. You can copy paste this URL, or you can double click it to watch this lathe machine operation and milling machine operation. Then you should list the different types of operation done in these videos, the lathe machine and milling machine. You can put your answer on a yellow paper, one whole yellow paper, to be submitted next meeting. Okay, if you have any question, please feel free to ask me or message me. Thank you and God bless.